Okay, so the problem we're solving tells us that in the first level there are 5 glass panes. So we know that A1 is equal to 5, and it tells us that every next level has 2 more than the other. So we know that our common difference is 2. Right. And what they're trying to say is that they want us to show why this formula for finding the series of n number of glass panes is equal to n squared plus 4n. So all you have to do to solve this problem is pretty simple. You need to remember the series formula here and just try to apply with what you have. So Sn equals n equals 2a1. So a1 is 5, so 2 times 5, 10, plus n minus 1. We don't know what n is, so we'll leave that as n, times the difference, which we know is 2, so we put 2 here. All of this times n over 2. So now what we got to do here is we're going to distribute the 2 inside this parenthesis, which is what we have. So we're going to end up with Sn equals 10 remains. So 10 plus, and then we do 2 times n and 2 times negative 1. So plus 2n. I'm just going to erase this so it doesn't confuse anyone. 2n minus 2 times n over 2. So now we have 10 minus 2, so we combine like terms, and what we're going to end up with is a parenthesis that looks like 2n plus 8, 2n plus 8, right? That's going to be inside our parenthesis. So I'm just going to erase here so we can show better. Sorry. So Sn is going to be 2n plus 8 times n over 2. So now what we do again is we do the distributive property again with the n in now. So we do n times 2n and n times 8. So what that's going to give us is going to be Sn equals 2n times n is 2n squared plus 8n over 2. So now we simply simplify it. 2 divided by 2, 1. And 4 divided by 2 is 2. So we're going to end up with Sn equals n squared plus 2n, which was our original formula. So we have now successfully shown that that's how you apply this.
Right.
Okay, so in this problem, we're going to use sigma notation to find the sum of an3 equals 3n minus 1 up to a20, because that's what they asked. So when you're doing sigma notation, what you're going to get is something like this. And here on top of the sigma, you're going to put up to the number your sequence is going. So 20, because that's what they told us. And here you're going to put n with your starting number, which in this case is 1. And this is equal to, here what they told us, that is the equation for the sigma. So 3n minus 1. So what does this mean? If you want to find the sequence for what this is, you're just going to have to write out how many terms you put here. So plus 3n minus 1 plus 3n minus 1 up to 20, right? And then in every n, you're going to substitute for 1, 2, 3. So for example, if you substitute this n for 1, it's going to be 3 times 1 minus 1. So this is going to be 2. So the first number in your sequence is 2. If you substitute this one by 2, then you're going to have 3 times 2, 6, minus 1, 5. And so on and so forth. And this is how you get to your sequence. but you want the sum of this sequence up to 20. And so since you don't want to do until 20, there's an easier way to do this. So, right, remember that the sum formula, you have this one, but you also have, so as I was saying, the series formula is this, and what you want really is the sum up to 20. So what you need to do, it's this times n. So what you need to do is you just need the first term and the last term. And the first term you got here, 3 times 1 minus 1, that's going to be 2. And so now you can find the 20th term by just doing 3n minus 1 and substitute in 20 here. So 20. And this is going to be 3 times 20, 60, minus 1, 59. So now you have your a1 and your an, and you can just plug that in. So you're going to have Sn equals 2 plus 59 times 20 divided by 2. So this here gives you 61. So Sn equals 61 times 20 over 2. And let me just do that really quick. Can you give me your phone? And that equals to 610. So you have that Sn equals 610. N being 20, of course. So S20 equals 610. And that's how you find it. Okay, so we're trying to find all these factors with this function.
What function is that, Sophia?
It's y equals this. So to find the y-intercept, we clearly can't use it like this. So what we're gonna do is we're gonna turn this into a function in the standard form. So, okay, we can just pass this 2 to the other side, and since you're gonna be, try to do that now. X minus 2 times x plus 8. So we do like this, and we're gonna get x times x, x squared, x plus x times 8 plus 8x, x times negative 2 minus 2x, and negative 2 times 8 minus 16. Right? Right. So, okay, wait, let's not forget that there's the 2 here dividing it, okay? So, it's gonna turn out x squared plus 2 plus 6x minus 16, and all of this is over 2. So since like the y-intercept is always the c, it would be negative 16, but since it's divided by 2, we can just simplify it, and that's gonna turn into negative 8. So we know that the y-intercept is negative 8, right? Right. Perfect. What?
Didn't you get rid of this and put it on the other side?
Yeah, no, not for this part, sorry. So now we're gonna try to find the x-intercepts, and that's when this is 0, sorry. So now you can just put this on the other side, so times 2, 0, got rid of it. And if you had it in standard form, you'd have to solve with the quadratic, but since it's already been simplified for you, you can just say that x equals plus 2 and negative 8, because it's these results. Opposite of them, right? Because you would have x minus 2 equals 0, then x plus 2, so it would equal positive 2. Right. So we have our vertex at negative 3, comma, negative 12.5. So when it asks you for the axis of symmetry, you know that it's negative 3. So you're just going to say x equals negative 3, because the vertex is always in the axis of symmetry, because it's the point between them. So yeah, when it asks you for the axis of symmetry, you're gonna write -3 equals x. And there was another question that it asked when f of x was 12, what was the other thing? And one of the values of x was -10 to prove that the other one was 4 or -4. So what you would do then is, since you have the axis of symmetry, you would write like -10 plus the value that we're trying for over 2 equals the axis of symmetry, which is -3. So you would do -10 plus x equals 2 times -3, -6. So then plus 10 and plus 10, x equals 4. So then you proved it that if f of x was 12, the other value would be 4. So that's it.